Hello! Untitled Chapter presents Mr. Lawrence here, and this video is going to get posted late on December 27th, so if you went looking for it, I apologize. It didn't get posted sooner, but things have been a little crazy the past couple days. But this is video. It's just going to refresh your memory and introduce a new topic that we're going to be learning on Monday. So anyway, let's get down to it. Oh, by the way, I have to mention, just so your parents can hear, if you're watching the video at home, how proud I am of you over your midterm scores. Yeah, you guys did a great job. I'm very proud of you. All right, anyway, so let's hit the second semester building off of that momentum that you took into the midterm. So remember, we learned about slope, how to calculate slope from 2 points, right? And here we have this equation where we subtract the y's, we subtract the x's, right? And I actually gave us 2 points here so we could practice. Our slope is going to be, let's see here, let's make this x1 and y1, and that x2 and y2. Now, of course, you could have made these x2 and y2 and these x1 and y1. It doesn't matter which point you call the first point, which one the second. It does matter that if this is the first x, this must be the first y. If this is the first x, then this must be the first y. You can't mix and match. All right, so I'm going to take -1 minus -4, and that'll make that -1 plus 4, right? Because subtracting a negative is the same as adding a positive. So my numerator is going to be 3. And then my denominator will have -5 minus 10, which will be a -15. I'm going to simplify that down to -1/5. And you're saying, well, Mr. Lawrence, you moved the negative. Well, yeah, we typically don't leave a negative in the denominator, right? We either put it in the numerator or in front of the fraction. Okay, so that would be our slope. That would be the slope of the line that passed through these 2 points. If you graphed these 2 points and counted your slope, you would have to go down 1 and right 5, and down 1 and right 5, and it would help you produce your line. Okay, now remember, sometimes we get a numerator that's 0, okay, and this slope is 0. This is a 0 slope, and this would be like a horizontal line, right? It'll be completely level. There's no rise, but there is run. See my 2 points on here? It kind of looks like a TIE fighter. All right, so 0 rise, but we ran a distance, didn't we? Okay, sometimes we get a slope that looks like this. And this is when there is no slope. Yeah, there's actually no slope because you're not allowed to divide by 0. This would be a vertical line because it only has rise, but it does not have run. Okay, and so there is no slope. If you look at points A and B here, right? As you move from one to the other, you do have rise, but you don't run anything. Nope, no running going on. All right, so we learned about slope, and we learned about direct variation, and we also learned about slope-intercept form. And they're almost the same thing. They have slightly different applications, but notice then direct variation, there's nothing added here. Well, technically there is. What's added is always 0. Remember, for 2 things to be to vary directly with each other, the line that you produce is going to have to go through the origin. If it doesn't go through the origin, then it's not a direct variation situation. Okay, direct variation simply means that if x is going up, then y is also going up at a proportional rate. Okay, it's for 2 things to vary directly. So we have y equals 8 when x equals 3. Find y when x equals 10. Well, the first thing we do, we have to find k, right? Our constant of variation. So we say 8 equals k times 3. We solve for k, which tells us that k is 8/3, right? And then we want to find y. We don't know y. We know k is now 8/3, and it says x is 10. So we multiply here, and we'll be able to figure out y. And I don't see anything that's going to be able to simplify. So y, or 80 is going to be, excuse me, y is going to be 80/3. Let's see, if it was 81/3, that would be 27 on the nose. This should be 26 2/3, right? Because if it was 81/3, 81 divided by 3 would be 27, right? And this is 1/3 less. See how I did that? 80 is 1 less than 81. and we're dividing by 3, so it's 1/3 less. So I took 1/3 away from 26/3. Okay, by the way, if you have trouble with fractions and you want to know how I did it, come on in. I'd love to help you. You guys are so smart. They'll catch you on in 5 or 10 minutes. Okay, now slope-intercept form. Remember, y equals mx plus b. Remember that y must be alone. If the y is not alone, you're not in slope-intercept form. Oh, why do they call it slope-intercept form? Because when the y is alone in a linear equation, you know the slope and you also know the y-intercept, right? The y-intercept. Here's the slope, here's the y-intercept. Now I look at this equation, y is not alone, so I'm going to work to get y alone. First, I'm going to add 5 to both sides. When I do that, I'm going to get 2y equals 3x minus 2. And then I'm going to divide by 2. I have to distribute over there on the right-hand side, and y is going to be equal 3/2 x minus 1. All right, so I am going to plot the y-intercept at 0, -1, and I'm going to rise 1, 2, 3, and run 1, 2, and rise 1, 2, 3, and run 2, and that'll produce my line. Of course, I could go down 1, 2, 3, back 2, and notice I still get the same line. All right, so I'm just going to make that a little bit longer. And this has all been review up to now. There we go. Okay, so here comes the new stuff. All right, the new stuff is called point-slope form of a linear equation. Now, before I tell you what it is, I want you to take the slope equation, how to calculate slope, and notice I made a slight differentiation to it, and you'll see it's no big deal. And I want you to write this down, and I want you to put this denominator in parentheses, okay? And you can put the numerator in parentheses too. You'll see why in a second. And I want you to pause the video after I give you the next direction. I want you to multiply to get rid of my fraction. Yeah, like if I had x over 2 equals 7, well, you'd multiply by 2 over 1 and multiply by 2, and you would get x alone, right? You'd get rid of the fraction. So I want you to multiply and get rid of the denominator here. Get rid of the fraction, okay? Okay, if you're still watching, I'm assuming you've already done it. I'm going to do it, so to make sure you did it right, put that over 1, and then over here, I'm going to do x minus x sub 1. Okay, now I'm going to rewrite this side using the commutative property. So I'm going to get m times x minus x sub 1, and that's going to be equal to y minus y sub 1. And this is point-slope form. Some of you will see it written this way, where it goes y minus y sub 1 equals m times the quantity of x minus x sub 1, which is just the same thing. I just used the property of equality, right? Okay, now why is this useful? Well, you can probably tell me what m is. Yeah, m, of course, is your slope. Yeah, notice it's called point-slope form. So m is the slope, okay? Now, the trick is there's a point hidden in here. The point is x1, y1. Yeah. And I want you to notice something very important. See this x sub 1 I just wrote here? And see this x sub 1? What's the difference? Do you know, Ariana? I'll bet you do. Yeah, the blue one's negative. The one here changed signs, didn't it? Look at it in the y's. It changed signs. So to get your point, you've got to change the signs from what you see in the equation. So let's come down here and let's see this equation. This looks like point-slope form. We've got y. Wait, it's supposed to be minus. Well, maybe that's because it's minus a negative, right? Y minus -5 would change it to y plus 5, right? And then there's this number times the quantity of x minus 4. Can you tell me what the slope is? Well, the slope is going to be 2 over 1. Yeah, our slope is 2 over 1 from right there. Okay, now my x-coordinate isn't -4. My x-coordinate is +4. My y-coordinate isn't +5. It's -5. I can use this information to graph my line. I could plot the point 4, -5, which would be right here. And then I can rise 2 and run 1 and rise 2 and run 1. Yeah, instead of telling me the y-intercept, point-slope form tells me any point and then the slope. So I can do it just as easily as slope-intercept form. Yeah, so it's pretty neat if you think about it. Let me put some arrowheads on there. Let's try one more. Oop, I don't have a graph here ready to go. All right, let me get a graph out. There we go. Okay, so why don't you see if you can do this one totally on your own? I know you've only had one example, but you guys are so smart. Give it a shot. You see if you can find the slope, find the point, okay? And then produce your graph. All right, here comes my solution. So I'm going to say the slope is -1/4. My x-coordinate will be -1. My y-coordinate will be +3. So I plot the point -1, +3, which is right there. And then I rise -1 and run 1, 2, 3, 4. I rise -1 and run 1, 2, 3, 4. Or I could have risen 1 and gone back 1, 2, 3, 4. And of course, there's an infinite number of points on this line, but 1, 2, 3, 4. I only have to show 2. I show more than 2 because it makes my line easier to be accurate. Excuse me, I didn't say that very well. It allows me to draw it more accurately. All right, that's going to be it for the video. Just a quick recap. We reviewed sections 5.1, 5.2, and 5.3. All right, this is 5.4, and it's called point-slope form, right? Point-slope. And they call it point-slope form because it's for a linear equation. When you're in point-slope form, you know a point on the line, not necessarily the y-intercept. It could be the y-intercept, but probably not. And you also know the slope. Okay, the slope is pretty obvious. It's right there, m. And remember that the point, you change the sign on the x-coordinate and you change the sign on the y-coordinate. So then you plot the point and then you use your slope to get your other point. So if I had an equation like this, y plus 4 equals -3 times quantity of x minus 7, my point would be 7, -4, and my slope would be -3 as a fraction, -3/1. Now remember, Excel doesn't like the fraction part, okay? But when you go to graph, the fraction is very useful. All right, that's going to be it for the video. Mr. Lawrence signing off, saying I hope you enjoy the rest of your break. Have a good night, everybody.